Good afternoon, my name is Marcus Case, and today I'll be providing a decision briefing on orbital debris. So here's a quick overview of what we're going to be covering today. I'm going to be going over an introduction, background, problem statement, research and analysis, threat of orbital debris, solutions for orbital debris, and then a recommendation on those solutions, a summary, and some references. So who is this decision briefing intended for? It is intended for General John W. Raymond. So he's the Chief of Space Operations. He's the person in charge of the United States Space Force. So what is orbital debris? Orbital debris is natural or man-made, and it's orbiting around our Earth. So why is it so dangerous? Because if this orbital debris comes in contact with one of our vital assets in space, it could be detrimental to our mission. So here's some background information on space debris. So currently, there are more than 23,000 pieces of tracked orbital debris. And that number actually just went up by about 1,500 due to Russia's anti-satellite missile test. There are also millions of pieces of orbital debris that are too small to be tracked. This is about less than 10 centimeters in diameter. And no matter the size, this stuff is dangerous because this debris has been recorded traveling up to 17,500 miles an hour. In 2009, a defunct Russian satellite and an active US satellite collided with each other. This is our main concern. We do not want this to happen. This actually added 2,500 pieces of tracked orbital debris and millions of pieces that are smaller. These small pieces are still dangerous because like I said, they're moving up to 17,000 miles an hour. And the most dangerous ones are in between 10 centimeters in diameter and 1 centimeter in diameter, because our assets up there are equipped with debris shields, but anything larger than about a centimeter is too big for those shields to stop. And we can't track those smaller pieces either, so we can't perform avoidance maneuvers. So if something like that collides with one of our assets up there, it'll be detrimental. The main concern is something that was proposed by NASA scientist Donner Kessler. So he proposed that with the amount of debris that we have up there right now, we're going to have collisions every once in a while. When those collisions occur, a lot more space debris is going to be added up there. With more space debris, there's going to be more collisions until we have that exponential effect of a curve where we essentially just have a ton of space debris up there and space is unusable for mankind. So what is my problem statement? My problem statement is orbital debris poses a threat to US national security. We need to address larger orbital debris in low Earth orbit. So we don't want to focus on the 1 to 10 centimeter stuff or even something that's a little bit bigger. We want to focus on the big stuff so it doesn't create a lot more orbital debris. We want to reduce the threat to assets and future space operations. So for my research and analysis, I looked into what assets are at risk. And then I looked into what are the importance of these assets. I then looked into some solutions for how to remove space debris and reduce the threat to these assets. And then I weighed these solutions. The two main weights that I did was cost and effectiveness. I also looked into some other things like the effect on the environment. So what is the threat of orbital debris? What's at risk? Our main thing up there that is the most important to our US national security is our satellites. So whether it's GPS, communications, ISR, missile detection, meteorology, all of that is vital to our military operations. And if we have one of those satellites go down, it's going to have a big effect on our operations. This will also affect our civilian life too, because our civilians rely on GPS, communications, weather satellites, and also it provides stuff like TV and radio communications to us. And that'll be unavailable if we lose some of these satellites. We're also going to lose the ability of research in space. So things like the Hubble telescope and other space operations that we conduct where we launch rovers to other planets, we're not going to be able to do that. We're not going to be able to learn more about space. So what are some possible solutions? I did some research and these were the three main solutions that I came across. First one is tracking debris, which we are currently doing. So it's the most cost-effective method because it'll cost us $0 more in added budget to continue doing it. The main issue with it, though, is it doesn't remove the threat of multiplying debris. And Donald Kessler's theory will still apply and may still come true if we just continue to track debris. So then I came across these two other options, which are deorbiting and graveyard orbits. So deorbiting, we have to launch a spacecraft. That spacecraft will rendezvous with a piece of orbital debris, capture it, and then slow down where it'll fall back into Earth's orbit and either burn up in the atmosphere or fall into the ocean somewhere where it won't hurt anyone. Graveyard orbits are similar, at least in the beginning. But once the rendezvous occurs, instead of slowing down and falling back into Earth's atmosphere, the spacecraft will accelerate and change the course of that debris. It'll change the orbit of that debris into an unused orbit by active satellites, and also it'll be a larger orbit, so there'll be a smaller chance of collision occurring. Both of these operations, deorbiting is a little bit more expensive than graveyard orbits, depending on the situation typically. Deorbiting is estimated to cost around $130 million. I think deorbiting is definitely the most effective, but it's also nice to have another option like graveyard orbits. So what is my recommendation? I think we should continue to track debris to protect our assets up there right now and also begin deorbiting operations. Right now, the European Space Agency is already working towards these space operations and is actually projected to launch a deorbit operation in 2025. So here's my summary. We went over an introduction, background information, my problem statement, research and analysis, the threat of orbital debris, some possible solutions, my final recommendation, and that's about it. If you have any questions or concerns, please feel free to contact me at my email or phone number, which are provided right here. Here are my references. Thank you.